There are some pretty substantial differences among our courses. Melanie Stiers teaches her introductory cell biology course primarily to first-year biology students, and it is a relatively large course. Pete Van Zant's evolutionary ecology course has smaller sections and is taken mostly by sophomore and junior biology majors. Finally, Kate Hayden's biochemistry course is also fairly small and is taken by a mix of junior biology and chemistry students. However, each class has a flipped or blended learning component to it. That is, they have several class periods where students watch pre-class videos that allowed each one of us to make time for in-class activities. Some of our pre-class videos included externally produced animations that help students better understand course concepts. Other videos were made by instructors for each course and provided students lecture material and slides that students could watch repeatedly and review prior to classes or exams. In all cases, these videos freed up class time for us to add active learning components that were focused on building students' critical thinking skills, such as their ability to evaluate information, think creatively, solve problems, and integrate a diversity of information sources. These in-class activities also were aimed at improving their understanding of more difficult concepts and material from the course. We were interested in seeing whether students improved these critical thinking skills, so we used the Critical Thinking Assessment Test, or CAT, which was developed at Tennessee Tech. The CAT is a 1-hour open-ended assessment tool that consists of several questions that present information, ask students to interpret that information, then ask the student for other possible interpretations for that information. Finally, students are asked about other information that might help them better understand the information that was originally presented. Note that while the example here involves a scientist, the CAT isn't discipline-specific and has been used for all college students at all levels because no prior content knowledge is assumed. Research has shown that students don't show improvements in critical thinking skills without intentional and explicit scaffolding, so each of us independently developed in-class critical thinking activities, known as CAT apps. These gave students practice in integrating information, interpreting figures, and developing alternative explanations. In other words, we tried to guide students into thinking critically. Our CAT apps were all specific to our own classes, but the same principle can be applied to all disciplines across campus. We tested students in our classes both at the beginning and the end of the semester, which allowed us to determine whether the focus on critical thinking that we spent in our classes helped students improve their critical thinking skills. We also assessed students' perceived gains in the course with a pre-course, post-course online survey that we administered using the SOLG website. This gave us the ability to quantify the students' perceived gains and compare them to the objective assessment of their gains that was measured with the CAT.